Hello everyone, my name is Johan Moya. I am 18 years old and I am a mechanical engineer student at X University in Colombia. I'm currently in my third semester.
Hi there, I am Samuel Velásquez. I am 18 years old, studying mechanical engineering at X University in Colombia. I am in the third semester too. Today we are going to talk about some interesting application of the first law of thermodynamics in mechanical engineering.
That's alright, Samuel. The first law of the thermodynamic is a fundamental principle that states that energy cannot be created or destroyed, only transformed from one form to another. It's essentially the law of conservation of energy.
Exactly, Manuel. Mathematically, we can express it as internal energy variable is equal to total head minus total work, where internal energy is the change in internal energy of the system. Um, Q is the heat added to the system, and W is the work done by the system main content.
This law has a numerous applications in the mechanical engineer. Let's start with one of the most common, internal combustion engines, which power most of our cars.
That's a great example. In an internal combustion engine, chemical energy from fuel is converted into thermal energy through combustion, which is then converted into mechanical engine that moves the vehicle.
The efficiency of this process is directly governed by the first law. An engineer designed an engine must account for all energy, transformation, and three to minimize losses in the front or the head zone and friction.
Another important application is in the HVAC system, heating, ventilation, and air conditioning. They system rely on principles of air transfer to maintain comfortable temperatures in buildings.
Right. For example, in air conditioner, the first law helps you track how thermal energy moves from inside the building to the outside. The refrigeration cycle allows compression and expansion of refrigerant to absorb heat from inside and release outside.
And let's not forget about power plants, whether it's a coal plant, natural gas facility, or nuclear power station. They all use heat to generate electricity. The first law helps engineers design efficient turbines and generators to maximize the conversion of thermal energy to electrical energy.
That's true. And a typical thermal power plant only about a third of 4% of the fuel's energy is converted to electricity. The risk is a lot as was the head, which is a way improving efficiency even in small percentage can have a huge impact of fuel combustion and environment impact.
Another application in the field is the material processing. Heat treatment of metals, for instance, involves careful, controlled heating and cooling process to after the materials properties.
Yes, and the first law helps us calculate the energy required for this process. For example, when designing a heat treatment furnace for steel, engineers need to know exactly how much energy is needed to reach certain temperature conclusion.
As mechanical engineers, understanding the first law of thermodynamics is essential for design energy efficient system, from small device to large industrial process.
Absolutely. And as renewable energy becomes more important, applying this principle helps us design more sustainable technologies like solar thermal system or geothermal power plants.
That's right, that's right. The first law is not just theoretical concept, but a practical tool we use every day in mechanical engineering to solve real world problems.
Well, that's all for today's podcast. Thank you for listening to our discussion about this application of the first law of the thermodynamics in mechanical engineering.
We hope you found it informative. This is Samuel Velásquez.
And Johan Moya from X University in Colombia. Goodbye and see you next time.